Hello, this is Andrew at Hexacrafter again. This is part 3 of our video series of the assembly of the HC650 and 800 Hexacrafter. And in this video we will try and run through several steps of the assembly process, starting with step 4A. At this point a decision needs to be made as to what type of electronics are going to be used for the aircraft. In step 4A, you see an example of what might happen if you were using a WKM. When using the WKM on the top center plate, you want to remove the center portion that's marked by the outside edges of the elongated holes. When you cut that out, I use a Dremel cutoff tool. It creates the hole for the WKM module, IMU, to penetrate through the top plate. Another option, as shown in steps 5 and 6, has to do with the selection of maybe a NASA or a hoverfly flight control system. When using a NASA, we recommend that you use the 4 screws closest to the area that would be removed for the WKM. And then when using the hoverfly electronics, we have drilled the holes required to mount their electronics, and they're clearly marked in the instruction manual, as well as the parts list has the areas to be cut out and marked. So at this point, that decision needs to be made, and then what standoffs you apply in what way to this plate depend on how you want the airframe to look above the top center frame. One of many examples that we'll use here today will be WKM, and again, we've already handled step 4A on the instruction module. We will jump to step 5, which is to apply the standoffs to the correct holes. We need 4 standoffs for the way that it's actually shown in the assembly diagram. And basically we use the 4 holes closest to the hole we've cut out. And the 3mm by 6mm cap screw comes up through the bottom, and the hex standoff mounts to the top. In this particular case, we're using a 23mm long hex standoff, but again, they can be adjusted with some of the additional hardware provided in the kit. If you don't need the 23mm, which you won't clear WKM, you can use a 10 or 15 or 20mm standoff to lower the profile of the flight electronics if you want. So at this point, we would have completed step 5 of the process, whether it be WKM or the hoverfly moved out to the next hole out. Again, you can Loctite these fasteners if you wish, but basically that would be step 5, and it can be reconfigured in many different ways depending on how you want things to look above the main plate. For now, we'll set that step aside, and we're going to actually jump past step 6, which deals with the rail assemblies, and jump on to step number 7, dealing with the mounting of the power plate. So in order to do that, you need the electrical power plate assembly. You will need the power distribution board, and you'll need 8 3mm by 6mm cap screws and 4 10mm standoffs, and that's also still included in the kit. The way it mounts, as you can see in the diagram, is you basically take the 3mm by 6 cap screws and come up through the holes that are on the perimeter of the cutout and apply a cap screw through the bottom and a 10mm standoff to the top side of that assembly. And you do that for all 4 corners of where the distribution panel will mount. Again, these all can be Loctited if you wish. I'm just putting it together for display purposes and so that you can understand how this kit goes together. So as shown in the diagram, we have the 4 10mm standoffs on the top of the electrical power plate, and on the bottom are the 4 cap screws 3x6. The final step in mounting the power plate is to mount it to those standoffs. It creates a gap between the power plate and the power distribution board to allow the wires to run through. And it gets a 3mm by 6mm cap screw going down through the power distribution board into the standoff, one in each corner. And again, you would tighten these all down with the hex driver and apply Loctite to the ones that you feel you wish to. So that is mounting the power distribution board as shown in step 7. Now we're going to back up a little bit and show you how a frame, a load rail assembly goes together. I will only assemble one for the purpose of this video, but you have a 12mm load rail. In this particular case, since we're only assembling one, we only need 2 grommets. We'll need 2 pair of load rail mounting brackets, the aluminum extrusion pieces. We will need 4 3mm by 30mm cap screws. We will need 4 hex standoffs. The ones provided in the load rail assembly are 15mm. However, you can again just adjust up the load rail tighter to the bottom of the frame assembly or further away from the frame assembly as you might need for loads that you would have under by using a longer or shorter standoff at this point. And finally, you will need 4 3mm by 6mm cap screws. So the load rail takes a grommet on through the rail on either side. And you will adjust the load forward and backward with these grommets as necessary to balance the load of the hexacopter when you get to that point. You want to try and align the grommets as close to where you feel that you're going to initially be to keep the load balanced so that they line up with the holes of the power plate. And the load rail mount brackets just basically push onto the grommet on either side, and the 30mm cap screws come up through the bottom of each one of the holes in those assemblies and go into the hex standoffs. And then on the other end, the same thing. Kind of want to have them facing the same direction down. And once you start to torque and tighten down on the 30mm cap screws, the grommet will compress and the load rail will become fixed and non-movable. So that's the way it'll look once the mounting brackets and the standoffs are mounted through the 30mm screws. And then it's going to fasten to the electrical power plate. And one of the things that's important to note is the holes that it mounts on, the rails mount on the end of the electrical power plate. The hole closest to the middle of the board and the one corresponding equal distance to that, these 2 holes here, are to space your load rails at 60 centimeters center to center, whereas the outermost hole and the matching hole with it, which would be the second hole over from the center, are used to mount the load rail at 80 millimeters on center. And you'll need to make that decision at this point. Our landing gear and our accessories are designed around a 60mm center line, and that's where we're going to mount them in this example. However, if you're using a photo higher landing gear gimbal assembly, you are going to need to mount it at 80 centimeters out at these two holes to get the 12 millimeter rail to work with the location that you need. So the electrical power plate goes on the top and the load rails go on the bottom. So this is an example of the way it'll look. Obviously there'll be a second load rail mounted on the opposite side. You can see that we have the load rail mounted. There'll be another one mounted as part of this step, as well as the power distribution board mounted to the top side on standoffs of the power plate. Now for the purpose of this video, I want to show you what the completed item looks like with electronics. This is once you get all the electronics mounted. This is very similar to the way it'll look depending on which ESCs you're using. In this particular case, you can see we have our 6 ESCs mounted and strapped down through the holes provided to strap them down. And the wires run underneath the power distribution board, up into the power distribution board, and then they're soldered from the top side. This is a really effective, neat way for wire management, and it makes it very easy to make the solder connections on the top. In this particular application, and this is what I recommend, that while doing your soldering, you make some additional power takeoffs for other accessories, like lighting, maybe FPV systems, or other electronic needs you might have that are going to come off your main power. I typically provide 3 additional power takeoffs and put either an XT60 or Dean's type plug on them to allow additional accessories to be plugged in. So this is what the final finished item would look like. I just want everybody to see, and then obviously the main power coming from the batteries comes into the power distribution board and is soldered to that as well. And while I have the time in this video, I want to show you how this interfaces with the main frame. This is the frame we built in the first couple steps, first couple videos, and I've mounted one motor here as an example so that you can see that the motor's mounted, the wires run through the tube, and then they come out of the tube and go down through one of the holes provided in the main frame and come out through the bottom of the main frame where the power distribution board is going to mount on the standoffs that we installed in our previous step. So at this point, this is where you'll take the time to properly, lengthen, or set the wires to the length you need, put bullet connectors on them, get them ready to plug into the power board assembly, which then mounts down over the standoffs that we had. And basically there are 8 3x6 millimeter screws that go down through the standoffs to mount the power plate. It's a little clearer without all the wires and standoffs, but it mounts in this location and provides an air gap for all the wires to go underneath and get into all the ESCs and keep everything cool. So that's it for this step of the video. We covered the load rails and the power board assembly. Next video we'll discuss the mounting of that to the mainframe and finishing up the mainframe as we can. Thank you for joining.